All right, guys, welcome to Discrete Math Honors. Hope you're doing well. All right, so anyway, we're going to talk about Unit 2.2. This is Euler circuits and paths. It is pronounced Euler, not Euler. Okay. So anyway, in the 17th century problem posed by the residents of Königsberg, Prussia. All right, so the residents of Königsberg, Prussia, they always, and basically it was the king of Prussia. At the time, he wanted to go across all the bridges and start and stop at the exact same spot. Okay, so his castle was on one of the islands, okay, in the Pregel River, and he wanted to start at home, okay, go across every single bridge and end up back where he started. So he tried it, and I'd encourage you to see if you can try it, without lifting your pencil. Okay, can you draw a graph without lifting your pencil? Can you trace a line more than once? So let me do it real quick and just see. Okay, I'd suggest that you try. But anyway, so like if I start here, okay, so if I go across, okay, I've got to go down here, okay, and then I got to go up. I got to go across, back down, across the bridge. But the thing is I don't want to cross one of these bridges again. Okay, so it doesn't look like I can do it. You can't. I mean, this river pretty much extends for hundreds of thousands of miles. I mean, like if you keep on going, you're going to get to the ocean. So eventually you got to cross somewhere. Okay, it's not shallow enough to do it. So you need a bridge. Okay, to do it. So anyway, we can't get back to our start without crossing one of these bridges more than once. All right. So what happened? Well, the king was very concerned about this. So his smart people in the castle, they could not figure out a solution. So whenever you can't figure out a solution, what do? Well, you always go to a smart man. So Leonhard Euler, okay, it's not Leonard, okay, Euler, it's not that, it's Leonhard Euler. So anyway, he's a very famous mathematician, probably one of the smartest ones in all mathematics. He published over 500 works. Just to give you a heads up, that's pretty doggone impressive. Most PhD professors who have a doctorate in math are able to publish one, maybe two, in their whole lifetime. Okay, so he published 500 works, new things. He's considered the father of graph theory, and interestingly enough, he was totally blind the last 17 years of his life, and his son and daughter helped to write a lot of his papers. So he would speak it and say his thought process, and then his son and daughter would actually write that down for him. I think he had about 5 or 7 children. So anyway, so he's the one who came up with this concept. All right. So what did Euler find? He found that there's actually 3 different scenarios for all of these types of graph. Okay, about crossing edges once and once only. Okay. So he said it's possible to trace a figure by tracing all edges once and stop at a starting point. Okay, so you start somewhere and you stop at the exact same point. So let me do an example of that. So an example of an Euler circuit would be something really basic, is A, B, C, D. Okay, and he said, something super basic, like I can start here. Okay. I go down, go across, go back up. I end where I start. Okay, so I'm ending exactly the same place as where I start. So he also said that's an Euler circuit, so that's his first one. Okay. He said that the second one, so let me write this down. So this is what's called an Euler circuit. Okay. And he says it's possible to trace a figure by tracing all edges once and stopping at another point than where you started at. So this is an Euler path. Just a real quick example would be where an Euler path is, okay, so I start at A, okay, I'm going to B, going to D, oh, I end at C. I end, okay, I end there. So that's what's called an Euler path. And then the last thing he said is, sometimes it is impossible. Like sometimes, no matter how you do it, it can't be done. So the third one is what's called impossible. Okay, so let me see. So right now it's good. Okay, I'm actually still good. Okay, but if I have another edge, so let me say this is where I start. Okay, I've gone down, I've gone down, I've gone down, I've gone through, I've gone this one. I can't get to this last one, B to C, unless I cross an edge twice. So this original picture of this right here is an example of an impossible graph. Okay. All right. So those are three scenarios. You might want to pause it right now. Write those down. Okay. Terms. All right. So what did Euler discover? Well, the neat thing about this is that Euler actually discovered that there is a pattern to this that emerges. So he said an Euler circuit is a vertex that has every single degree of all vertices are even. So what do I mean by that? So let's do scenario number one. Okay, so Euler circuit. So if I have A, B, C, D, and E. Okay. So if I have this, okay. So I've got some shape that looks like this. What he said is that you can go over here to the side and you can make a degree. Okay. So if I have A, B, C, D, and E, then all I have to do is I just look at A. Okay. How many do I have coming off of A? I've got 2. Okay. That's the number of edges that are coming off of it. How about B? Well, I got 1, 2, 3, 4. Okay. C, 2. Okay. D is going to be 4. And then E is 2. If you notice, what are these? Every single one is an even number. Okay, and that's the big deal, is that they're all even. So as a result, this circuit actually works. I can pick anywhere. I can pick to start anywhere. I can pick to end anywhere. And it honestly doesn't matter where you end or where you start. Okay. So what I do is I call it the pathway. Okay. And there's literally hundreds, because it doesn't matter where you start or where you stop. As long as it's the same vertex. Like I could start at A, I could start at C, I could start at E, yada, yada, yada. Okay. The key is that I got to pay attention. So the pathway would be, well, I'm just going to start at E. Okay. So if I went from E, and the only hard part about this is that you got to pay attention. So I mark off the edges. So I go E to D, okay, D to C, C to A to B, and then once you go so far, you're sort of locked in, okay? So B, now the thing is that I can't go to E right now, because that's where I got to stop. So if you want to think of it, like where I start and where I stop have got to be the same. So now I've got to go B to D, D back to B, and then B to E. So did I start and stop where at the same vertex? The answer is yes. Did I cross every single edge? The answer is yes. Yes. So as long as you go slow, then you should be able to figure out the degrees. This is because the degrees are all even, this is an Euler circuit. And this is the pathway, okay? All right, so let's do the second one. So I'm going to try and keep most of this, okay? Let's see if I can get that without too much wiping off stuff. And then let me just redo this one. All right, so now the second one is an Euler path. The Euler path said we've got to have exactly 2 odds. Exactly 2 odds. So let me draw another one. So if I got A, B, C, D, and E, and okay, so let me do one more, and then one more right there. All right. So on this, let's count the degrees. Okay. So I've got A is going to be 3. Okay. B is going to be 3. C is actually 4. If you look closely, there are 4 there. D is going to be, you got to be careful there too. It's going to be 4. And then E is going to be a 2. So if we look at that, how many odd ones do I have? Well, these 2 are odd. Okay. They don't have to be the same number. It could have been 1 and 3. Okay. It could have been 1 and 5. It could have been 3 and 9. Okay. Any of those, as long as it's 2 odd and exactly 2 odd, then this is going to be an Euler path. Now the pathway is a little bit funny, so you got to be careful with that. So on this one, you've got to start and stop only where they're odd. Okay, only where they're odd. So for instance, I'm going to start at, I think I'll start at B. Okay, so if I start here, then this is where I'm going to end. I have to end at A. Okay, it's just the way it works out. So if I start at B, and I can go anywhere, honestly it doesn't matter. So I'm going to go B to D, okay, D to C, C to B, B to A to E, E to C, C to D, and D to A. Now if you notice, and the only hard part about this is that you just got to go slow and pay attention. I always mark off the edges as I do it, okay? And that way I can get my pathway. If you notice, I started and stopped at different locations, okay? So now the third one is if you have anything else, so if you have more than 2 odds, then it is impossible. And let me, for this last example, let me do the actual problem that we started with, okay? So, the actual problem that we started with was you had A, B, C, and D. So, instead of a river with the 2 things in the front, what he did is he actually said these are the bridges, B to D, B to A, B went to C, and then A went to C, and D went to C. Okay, so that river problem that we saw, it actually boils down to this, okay, whenever you're using vertices and edges. All right, so you have a degree. If you're wondering why, so you got this river, okay, you got these edges, okay, so this would be edge B, this would be edge C. This whole bank on this, the top bank is called A, and the bottom bank is called D, okay. So I've got 2 bridges going down here, I've got 2 bridges going up here, I've got a bridge between B and C, and I've got 1 bridge going to C and 1 bridge going from C to D, okay. So this right here is actually the exact same thing. So if you think of these as nodules or as vertices, okay, and the bridges as the edges, then this actually really does look exactly like that. All right, so now let me take this out. So now let's go ahead and look at the degrees on this. So if I have A, B, C, D, okay, so A, I've got 3, B, I've got 5, C, I've got 3, and D, I've got 3. Well, how many do I have? Well, I've actually got more than 2. I got 4 odd ones. So as a result, this is impossible. Like, you can't do it. So he told, so Euler, the way we even remotely know about studying this is that he told the king at the time, the king of Prussia, he said, yeah, you got either too many or too few bridges. So how could you fix it? Well, you could actually destroy bridges, or you could build some bridges. So of course that's much more expensive. So the king, he just decided, yeah, it's not that big a deal. So he's just going to go over a bridge twice. Okay, but that question actually brought up a lot of interest. Okay, and it made this for Euler. All right, so now let me say this is that it's a big deal for Euler because he got a bag of gold out. Yeah, probably about this big. Probably weighed 40, 50 pounds. So it's actually worth quite a bit of money. All right, so I will say this: there is an algorithm. It's garbage. I'm not going to go over it. It's really, for my approach, is that you do the degrees. Okay, figure out if it's an Euler path or Euler circuit. If it has 2 odd, you start at the odd ones, and you're going to end at the other odd. Okay. If it has even, you can start anywhere, and you just got to pay attention and go slowly, mark off, make sure you go through everything that you're going through, okay? Nice and neat. So, and it's best just to do that, all right? So now there's just a few last things that we got to talk about. The last things that we got to talk about are a digraph, okay? A digraph is edges with direction. So it's like what we were talking about the other day, where you have so you have like A, B, C. Okay. So let's draw something from this. So this will be a digraph. Okay. So a digraph is edges with direction. Okay. I usually think of it as one-way street. N degree is number of edges coming into a vertex. Okay, so N degrees. So like if let me put it way down here. So I've got A, B, and C. Okay, and for this up here, you've got the in degrees, and you've also got the out degrees. Okay, so in degrees, A has 1 in degree and it has 1 out degree. Okay, so one's coming in, one's going out. B has 1 going in, 1 going out. C has 1 going in, 1 going out. All right. So anyway, that's the in degrees are ones that are coming in. The out degrees are ones that are going out. And a Euler circuit, if the in degrees and out degrees of each vertex are equal. So in this case, everything is the same. So this is actually going to be a Euler circuit. Okay. So what I mean is that if I start at C, I can actually go around and I can end at C as well. Okay. All right. So anyway, that's it. Hope you understand it. You might want to go through it maybe one more time, or just highlight the parts that you're not sure about. But anyway, otherwise, head on to the practice and try those. All right. Hope that goes well. Have a good one. Giddy up. Oh, and the quote of the day is, the fog of war works both ways. The enemy is as much in the dark as you are. Be bold. And that is by Patton. All right. Thanks. Bye.